Assalamualaikum warahmatullahi wabarakatuh and salam sejahtera to all my students. So for today's lecture, we will cover chapter 2, which is high performance liquid chromatography, HPLC. Okay, HPLC sometimes referred to as high pressure liquid chromatography. Sometimes referred to as high pressure liquid chromatography and also high performance liquid chromatography. And HPLC is a form of liquid chromatography used to separate compounds that are dissolved in the solution. So your sample must be in the liquid form. So if you have a gas chromatography, so the form of gas is used to separate compound. Okay, high performance liquid chromatography is a powerful tool in analysis because it yields high performance and high speed compared to traditional column chromatography such as paper chromatography, adsorption, and these are due to the forcibly pumped mobile phase. So inside the HPLC instrumentation, they have a pump, and this pump will force the mobile phase together with the compound to be separated into the column. HPLC is a type of liquid chromatography where the sample is forced through a column, which is the stationary phase, composed of irregularly or spherically shaped particles, a porous monolithic layer, or a porous membrane by a liquid mobile phase at high pressure. So the mobile phase is the liquid and the stationary phase is column. So make sure you can identify the mobile phase and the stationary phase for each chromatography that we have learned previously, and also HPLC. HPLC is a separation technique that involves the injection of a small volume of liquid sample into a tube packed with tiny particles, which is 3 to 5 micrometer in diameter, called the stationary phase. So the stationary phase, inside the stationary phase, it contains a tiny particle. Individual components of the sample are moved down the packed tube column with a liquid mobile phase forced through column by high pressure delivered by a pump. And these components are separated from one another by the column packing that involve various chemical and or physical interaction between their molecules and the packing particles. So these separated components are detected at the exits of this tube, which is the column, by a flow through device detector that measures their amounts. And an output for this detector is called as a liquid chromatogram. So there are some steps for preparation analysis of sample by using HPLC. So first thing you need to do is you have to prepare solvent, which is the correct solvent. Very important for you to get the precise result, and it can save a vast amount of time spent troubleshooting such as spurious peak, baseline noise, and etc. Quality. All reagent and solvent should be of the highest quality, and HPLC grade reagent may cost slightly more than lower grade reagent. So HPLC grade reagent contain no impurities to produce spurious peaks in a chromatogram baseline. So HPLC has its own solvent, which is the HPLC grade solvent. And buffers, all buffers should be prepared freshly on the day required. So the buffer we use the freshly prepared because we want to ensure that the buffer pH is unaffected by prolonged storage and that there is no microbial growth present. Okay, next you must do a filtration. All HPLC solvent should be filtered through a 0.45 micrometer filter before use, and this will remove any particulate matter that may cause blockage inside the column. And after filtration, the solvent should be stored in a covered reservoir to prevent contamination with dust. And pump plungers, seals, and check valve will perform better and lifetime will be maximized. After you filter the solvent, you must flow the solvent inside the column first before you run the experiment. And you must need to do a degassing step before the freshly prepared mobile phase is pumped around the HPLC system. It should be thoroughly degassed to remove all dissolved gases. And dissolved gases can be removed from solution by bubbling with helium or by sonication technique, and also by using a vacuum filtration. So if the mobile phase is not degassed, air bubble can form in the high pressure system, resulting in problem with system instability, spurious baseline peaks, and so on. So we want to avoid this from happen, so we must do a degassing step first. This is the example of degassing that might create to improper way of graph or peak here. So this is a noise or a bubble present because of degassing step is not is skipped. Okay, this is the figure show the mobile phase when degas undergo a degas process. And the most efficient form of degassing is bubbling with helium or another low solubility gas. And it is recommended that the mobile phase is continually degassed at very low level throughout the analysis. And this will inhibit the reabsorption of gases over the analysis time. This one is the scheme of a HPLC system. Okay, this is called as a solvent reservoir. This one is the pump, and you will inject the sample on the sample injector system by using a micro syringe here. This one is the column and the detector, and all the solvent waste is collected in this solvent waste tank, and all this chromatogram will show on the computer or data integration system, and you can print the result based on the pick you got. Okay, we see the principle first, reservoir. Okay, and then undergo to pump section, and the pump section will pump the sample into the injector system, and the injector system will push a sample into the column, and you will get the result which appear on the detector. Okay, this is the flow of the HPLC instrumentation. Make sure you can remember the flow correctly. 1, 2, 3, 4, 5 steps. Okay, HPLC instrument consists of a reservoir of mobile phase, a pump, an injector, a separation column, a detector, a waste collector, and also a recorder. Compounds are separated by injecting a sample onto the column. So the different component in the mixture will pass through the column at different shades due to the difference in their partition behavior between the mobile phase and the stationary phase. Like I explained in our previous lecture, the concept is the same, whereby if the stationary phase is polar and the compound to be separated is non-polar, the compound is to be separated composed of polar and non-polar. And when the separation occur, because of the stationary phase is polar, so non-polar compound will elute first. So you can determine the non-polar compound that elute first is what is the component is that. Okay, so the polar compound that retain in the stationary phase, you can determine also by figure it out based on the peak appeared on the chromatogram. And the different component in the mixture will pass through the column at different rate. okay, due to the tendency toward the stationary phase. And the mobile phase must be degassed to eliminate the formation of air bubbles. We look at the reservoir of mobile phase. Okay, the gasser step. We use the gasser step to remove the bubble in the column that will cause band spreading. Okay, we have the isocratic elution system for the reservoir, and also the gradient elution system. For isocratic elution system, an elution with a single solvent means that it contains a single solvent. If the gradient elution, it contains two and sometimes more solvent system that differ significantly in polarity. As we can see here, they have um, four solvent, okay, 4 bottles of solvent. And the pump, the role of pump is to force a liquid mobile phase through the liquid chromatograph at a specific flow rate. During the chromatographic experiment, a pump can deliver a constant mobile phase composition in isocratic or gradient elution system. And the type of pump, we have 3 types of pump, which are screw-driven syringe, reciprocating, and the pneumatic pump. While for injector system, which is the part that you inject the sample here, it serves to introduce the liquid sample into the flow stream of the mobile phase by using a microsyringe needle and typical sample volume of 5 to 20 microliters only. And the injector must also be able to withstand the high pressure of the liquid system. And autosampler is the automatic version for when the user has many samples to analyze or when manual injection is not practical. Okay, for pump model type, we have isocratic, gradient, binary, and quaternary. For isocratic pump, it delivers constant mobile phase composition and a solvent must be premixed, and it is the lowest cost pump. For gradient pump, it delivers variable mobile phase composition, can be used to mix and deliver an isocratic mobile phase or a gradient mobile phase. For binary gradient pump, it delivers 2 solvent, and for quaternary gradient pump, it delivers 4 solvent. Okay, we look at the gradient versus isocratic condition. Okay, for the isocratic condition, we can see that the red line here, because isocratic, it is suits for mobile phase solvent that is remain constant with time, and isocratic condition, um, because it deliver constant mobile phase, it is used best for simple separation, so often used in quality control application that support and are in close proximity to a manufacturing process. For gradient mobile phase, the blue peak, we can see the peak here, and mobile phase solvent composition increase with time, best for the analysis of complex sample, often used in method development for unknown mixture, and linear gradients are most popular, for example, the gradient shown on this curve. Okay. Okay, next part is the column. Column construct from stainless steel tubing with range in the range from 10 to 30 centimeter. And the column stationary phase separated the sample components of interest using various physical and chemical parameters. And the small particles inside the column are what cause the back pressure at normal flow rates. And the pump must push hard to move the mobile phase through the column, and this resistance causes a high pressure within the chromatograph. And most common packing for column is silica particle, which are often coated with thin organic film. Heat detector, and the most widely detector are based on absorption of ultraviolet or visible radiation. Okay, we will look at the principle of separation in the next lecture. Thank you.